everybody, this is Becca with Empowering Pumps and Equipment. I'm very excited to have Cody Kaufmann back with us. And we're going to talk a little bit about plastic today. We're going to talk about plastic specifically in the industrial sealing industry, advancements, issues, developments, and the future. So, Cody, why don't you give a little detail on who you are, and then we can jump right in.
Yeah, I am Cody Kaufmann, Business Development Manager for SEPCO. Been in the world of plastics for a little over 20 years now. Yeah, it's all I've ever known. It's my life. Plastics are my life. I don't know if
I've
that's
never heard that one before, but I like it.
there you go. There you go.
So, to kind of start us off, plastic is a very generic term. What are the specific types of plastics that we're talking about when we refer to high performance plastics or industrial plastics?
Yeah, for sure. Plastics is a generic term, but when we're talking about plastics in the sealing industry, really it's thermoplastics, right? This is kind of a big, large group of materials that really thermoplastic really just means heat moldable. Thermo meaning heat, right? So heat moldable plastic. So these are the materials that can be formed with heat and that can be recycled. So we'll get to that conversation in a little bit, but these are plastics that can be reheated multiple times without significant degradation to their properties. So thermoplastics is kind of the bigger genre. But then there's things like thermoplastic elastomers, and your listeners might be aware of those materials like santoprene and even urethane materials. So these are plastics, they're actual plastics, but they have kind of elastomeric or rubber properties to them. So very flexible. And then materials like thermosets, right? These are materials that do not, they set and they do not change, right? You can't recycle them. So like epoxies is a good example of a thermoset. So acrylics and epoxies and those kinds of things. And then bioplastics, and that's another product we'll talk about. So in my mind, at least, those are like the main of categories of plastics: thermoplastics, thermoplastic elastomers, thermosetting plastics, and then kind of the world of bioplastics. So those are really that's what we're talking about in general.
Okay, got it. So, lots of different types of plastics, learning
There are,
something
yeah,
already.
for sure there are.
So why don't you talk a little bit about the biggest innovations in plastics that have happened over the past 50 to 75 years?
Yeah, so everybody knows PTFE, right? And that's another material that we'll talk about a little bit more too. But everybody knows PTFE, and that really is probably the single biggest, innovation in plastics. From about the 50s is when PTFE was originally invented and started using commercially. And yeah, we'll talk about the downfalls in just a little bit, I guess. But yeah, I mean, PTFE in terms of just the industrial applications, industrial sealing, much of the production and chemical production and energy production that we have would not be possible without PTFE. And then certainly in the electrical, aerospace, and even medical industries now, PTFE has played a vital role. So yeah, in terms of just, I would go so far as to say not only in plastics, but just in man-made materials.
Mhm.
PTFE is possibly the biggest innovation ever. And that may be a little bold, but I'll say it's pretty close. And there's some downsides to that, but we'll talk about that. And then PEEK. A lot of people know PEEK as well. PEEK recently is being used in medical devices and things a little bit later than PTFE, like in the 70s. But in terms of energy production, oil and gas production, medical, even in aerospace, PEEK is a lightweight, super strong material. Yeah, that is changing the world in a lot of ways. And then, of course, the other biggest innovation is the one that we're currently in, and that's the bioplastic revolution, uh, which remains to be seen how far that's going to go. But I think yeah, super important innovation that we're presently in.
Okay, I like it. And so, in terms of these, the bioplastics, the PTFE, and then PEEK, what roles are you seeing that these types of plastics are playing in the advancements of these industries? Like, are there specific ways that they're really able to meet the needs of industry?
Yeah, yeah, absolutely. Just a few examples, like planes. I won't go so far as to say planes can't fly without them, but I'm not sure if we would want planes to fly without them. um, and I'll explain that. I'll explain why. Light weighting is an important aspect of transportation. Fuel efficiency in cars and airplanes is important. So the lighter the vehicle is, the less fuel it uses. Right? I mean, that's just how it is. So part of our push to um, conserve resources and save the environment is less consumption of things, right?
Mhm.
And that means that they need to weigh less. We we are just a growing population with growing needs, and we need to make our certainly our transportation products way less and consume less resources. So um, yeah, plastics is a big part of that, right? So all the components that were previously aluminum or other alloys, we're finding high strength, lighter weight plastics and polymers that can go into those applications, and we're conserving millions and millions of pounds of and gallons of fuel and energy um,
Okay.
as a result of plastics, right? I mean, that's just facts. The other thing is in terms of wind energy, um, you think about these wind turbines that are exposed to sunlight constantly, exposed to elements constantly. Um, they need to be made from products that can withstand corrosion and UV exposure. And polymers, plastics fit that bill. So a lot of these major components on wind energy generation, um, they're fiberglass and carbon fiber filled thermoplastics, because they can stand the being exposed to sunlight, and they don't corrode. So things like solar energy require um, thermoplastics.
Mhm.
So yeah, I mean, those are just a few examples to say that the advancements of these industries, or the advancements of these materials in aerospace and healthcare and certainly energy, um, they're actually what's innovating, or they're actually what's driving a lot of this uh, clean energy and conservation. They really are.
That's interesting and definitely not something that you think about. Like you don't think to put the two together.
Yeah,
So that's pretty cool.
yeah, for sure.
So to kind of flip it a little bit, what would you say have been some of the biggest problems with plastics over that same time period?
Yeah, I mean some of the biggest, well, the biggest problem is the one that's well known now and has been for a while now, and it's the chemicals that are used in the manufacture of specifically fluorinated materials, but a lot of plastics. And that's the chemicals PFAS or PFOS, and PFOA is another one that's kind of really completely phased out now. Um, but yeah, I mean, I mean, I'm sure your listeners are well aware of some of these, but these are chemicals that are used in the manufacture for specific purposes. So they add to the non-stick and kind of water resistant properties of the materials, which is beneficial, especially like in when they use them for non-stick coatings and water resistance in fabrics and stuff. The downside is, of course, is that these chemicals, they don't go away, and they're toxic.
Yeah.
Um,
For us, like if it's the nonstick, like our pans and stuff that we're, ingesting. And definitely, I know with the PFAS, like that's a big deal. It has been over the last couple years, but continues to be a
Mhm.
big deal in the fluid sealing industry specifically. But really, it's again, we don't want to be absorbing these chemicals. So, like,
Correct.
something needs to be done about it.
And absolutely. And I think I don't know how far we want to go down this rabbit hole, but to make matters worse is that a lot of these big companies who were manufacturing these products were less than honest about the potential ramifications of these chemicals. So it's led to significant lawsuits
Mhm.
in some of these areas, to the point that a lot of the major players who even invented some of these materials are now they don't they're not going to manufacture them anymore because of the litigation issues. Which yeah, we can argue about whether that's a good idea or a bad idea, but I think ultimately uh, the biggest issues facing plastics is one, the toxicity of them, or the potential toxicity of them, and the fact that their recyclability and biodegradability um, is less than adequate, and that's probably being nice. So those are the biggest problems. They're not insurmountable problems, but they're pretty big issues,
Yeah.
and they should be. They should be.
Yes, they should be. So, in terms of kind of the recyclability, um, how do you, what are the efforts being done when it comes to recycling, sustainability, in the use and development of these plastics?
Yeah, I think a lot of the I guess a lot of the conversations surrounding them, and even I don't know if we're talking about regulations and policies potentially. I don't want to get ahead of myself, but I think what this does generally is it pushes innovation in a lot of ways. So anytime mistakes are made, right, or we understand the need for recyclability and sustainability, it should, and I think in this case it is perhaps more slowly than we would like. It pushes innovation. Like, we got to figure this thing out, right? Because we know and we've talked about a little bit the value of these products. We understand the value of them, um, not just in kind of making our everyday lives better or easier, but we understand the sustainability aspects of them. Like, I mean, if we want clean energy, we need plastics. Like, we need these products, so we got to figure out how to make them recyclable and sustainable. Uh, um, so um, so it pushes innovation, right? So I think that's one thing we're seeing. Um, but the other thing that I think that the push towards recyclability and sustainability on the negative aspect is it could threaten to dampen in innovation as we kind of just throw our hands up and like go somewhere else. Like, if we say, well, we can't make this work, let's just abandon this
Mhm.
whole plastics avenue, and let's go somewhere else and do something else. And I don't think that's necessarily the answer, um either. So I didn't really answer your question now that I think about it, but
I mean,
uh
I think it's both too. Like I appreciate that it's, it's not an easy answer, but it could, depending on how you view it, it could enhance that innovation or it could dampen it. Like that's just the truth of the matter. If it depends
yeah,
on how you feel about it and if you're willing to take on um, that task, I guess, of like
that
trying
challenge.
to make it better and figure out ways to be innovative with it, and create things that no one maybe has even thought of yet.
And I will say too that is happening, right? I talked to a guy the other day, who is in the middle of his, getting a PhD, and his kind of big thesis, or his, what he's doing is a biodegradable fluorinated polymer, a biodegradable fluoropolymer. That's his effort. Something that will replace potentially PTFE, that is safe and biodegradable. So, like, there are people that are working on this, and I think they're going to be success. They're smart people trying to figure this out. I think that we need to allow them the space to figure that out. Um, and I think smart people are going to figure. Smart people are going to be smart. That's just how
Yes. I like it. And it is like, give people a problem to solve and they're gonna do it.
yeah.
Pending that they have, the resources and ability to really venture into that and dive into it fully. And, with that, you know, speaking, you mentioned a little bit in terms of regulatory policies and the global environmental concerns that are shaping the plastic industry. And I do think that's part of that conversation of these people that are like sustainability and our environment is very important to them, especially the newer generations coming up into the industry.
Mhm.
So they are the ones that are wanting to spearhead this and find ways to do things differently.
Mhm. Yeah, yeah, for sure. And I think with regards to that, like oversight is always a good thing, right? And people act like at times that like governmental oversight is a bad thing, and I would say at times it can be, but checks and balances and oversight, generally speaking, always promote health and safety. That's just facts, like I mean that's why the U.S. government was set up the way that it does with checks and balances and oversight so that we guarded against kind of rogue individuals or rogue innovation and those kind of things. So I think the oversight that we're seeing, I think we can very easily, and I'm speaking specifically with kind of the PFAS, the Teflon stuff that's happening right now, but the oversight in general in terms of plastics. I think we can kind of balk a little bit about this oversight and complain that the government is trying to get in manufacturing business and all of this. And I think that's probably the wrong way to look at it. I think it needs to be tempered to such a degree that we can still allow innovation to happen, right? And that the advancements that need to happen can be funded and happen, But I think we also need to realize that uh, you know, this kind of oversight is actually a good thing. It is going to ultimately help help things be safer and better. So I don't know why that's necessarily a bad thing. But people complain about, again, this is taking it in a different direction. Maybe this is not boring, Becca. I don't know. But people always complain, like when the government overreaches in any, when it comes to like, I don't know, seatbelts in cars, we complain initially, and then um, so anyway, I'm not gonna get into all that, but I think that these kinds of things will, if handled properly, will promote good quality oversight that improves health and safety, and that, yeah, promotes the innovation that we need. And so, yeah, that's a long about way of saying I think the oversight and regulatory policies and things are both good and bad.
Mhm.
They really are.
Yes, and I agree with that. And then we also too like the voices in industry. I had mentioned about the fluid sealing industry, like that education, going and talking to the government and the different divisions and things, and that education piece and continuing to iterate on these policies and have input is very important to do, so
Mhm.
that everyone is informed and knows what they need to know. And then we can, make sure that we have policies that are helping us as a society, the manufacturers, everyone involved.
Yeah, for sure. Absolutely.
So I'd love to talk about the challenges and opportunities in transitioning to this biodegradable or more eco-friendly plastic alternatives. So can you speak on that a little bit for
Yeah,
me?
yeah, for sure. The challenge first. The challenge is performance. I mean that's the biodegradable plastics are a thing already, right? I mean there's lots of bioplastics, even even materials like 3D printable plastic materials that are kind of commonplace now, that actually is a bioplastic. It's a it's a basically a corn byproduct essentially. So a lot of these plastics that we're already using for kind of more common use, like we're a lot of bottles now are switching to a bioplastic, a lot of packaging and things. Um, so we're already there. Like the bioplastic revolution has already begun. The issue is performance for industrial applications. So these materials generally have a very low melting point, right? Low in terms of industrial applications. So 200 or below melting point. So they couldn't be used in any kind of high heat application. And they're not chemically resistant at all because they're made from plant-based products. So in any kind of chemical will degrade and attack them. So that's the challenge is performance. How do we make a biodegradable or plant-based uh, product that is also going to perform in these, kind of high intensity, high heat, chemically resistant applications. Um, that's the challenge. And it's not an easy one, and we haven't exactly figured it out, but the opportunity um, is can't really be understated, right? Because the need for plastics is going to continue to grow. So having having biodegradable plastics in industrial applications that can be recycled and be reused, um, that are cost effective as well, which I think is also going to be somewhat of a challenge. Um, yeah, I think is I mean, there's huge opportunity. The other challenge that I'll say that I think your viewers might be interested in hearing is in terms of bioplastics is the input or the feedstocks for these bioplastics often are corn or they're other food-based products. So when we look at increasing or transitioning more to bioplastics, we have to consider the fact that that is going to consume more food products.
Mm.
uh, the downside is that where are those food products going, right? World hunger is already a thing, so
Mhm.
that's another challenge that has to be considered is like this push to bioplastics. If it helps one problem, but creates another,
Mhm.
meaning further food shortages or further, crop or farmland disruption and those kinds of things. And the environment is negatively impacted as a result of us kind of needing to grow more corn so that we can support this bioplastics revolution. I think we got to balance those factors as well. So to say that this is an easy answer is it's pretty tough. I mean, there's a lot of factors at play, but I think it's necessary. We got to start moving in that direction because the alternative is just to continue to pollute our world with plastics and harm people with chemicals, and we don't want that either.
Yeah, and I mean with innovation too, like it feeds other innovation. So as we, continue on this path of looking into bioplastics and how we can utilize resources in a better way, other people are going to be like looking at alternatives to that, still in the same umbrella, if you will. But, maybe there's ways, and I'm sure there is, we just don't know about it yet, or haven't even thought about it yet, of what are other things, resources we can utilize that we could get to the same goal that isn't necessarily corn or whatever, whatever crop that plant product that we're using currently.
Yeah. Well, and I'll say that too is we're also learning new techniques for making use of the byproducts of other things, like the ethanol industry is a good example where before who uses corn products, the ethanol was the only kind of product that came out of that production. So you used up all this corn and you only got from it ethanol. Well, now because of advancements in like their manufacturing processes, there is not a single shred of byproduct that is not used for something in that, in ethanol production, for instance. So as we develop kind of more advanced manufacturing techniques, we'll even be able to use otherwise, waste products of manufacturing for even new other products. So anyway, that speaks to that kind of innovation within this. We'll figure stuff out. We'll
Mhm.
figure stuff out.
Yes, we will. So kind of on the same note of, the plastics and specifically when it comes to waste management or recycling of plastics, um, what innovations do you see in this industry that kind of hold the most promise for reducing global pollution?
Yeah, the biggest the probably the biggest, or like what I would personally like to see most, is this idea of being able to recycle these high performance plastics, not just being able to, like, because like right now, if you want to recycle PTFE, for instance, it's a mechanical process. You're just grinding it back up into a powder, and then you're either trying to remold it, which is done a little bit, but then you're using it as an additive in like grease or something like that. So it's just a mechanical process, and that's generally how all plastics are manufactured right now. So you turn in a bunch of plastic bottles, they're going to regrind them, remelt them, and remold something else. Well, the innovation in it's happening right now in recycling is actually taking that material back down to its original components. You're actually breaking down the polymer back down to how it was originally created. So you can use a process by which the polymer is taken back to a monomer again, and then can be remade into something else. So this is a recycling technique that could potentially be able to have products reused over and over again back into the same product that they were made initially, without any loss whatsoever um, of their properties. Because anytime you recycle a product, you do lose some bit of performance. But that kind of a recycling technique is I don't want to say unheard of, but it's fairly new, and it's not something we're doing right now. But that creates this really kind of a circular nature of manufacturing, where everything that you make, you will eventually get back and you can
Mhm.
remake it again. So there's like a sustainability there that I think is important. And there are people that are working on that, and I think that's the kind of the biggest, for me, the most exciting kind of aspect of recycling is being able to remake things back to how they were. um so yeah, and I think there needs to be more incentives for that kind of stuff. Again, I'm not talking too much politics or policies, but there needs to be more incentives for companies to do that kind of stuff, as opposed to regulations and punishments for people who don't. Right? It's a carrot versus a stick kind of an argument, and I think incentivizing that kind of innovation always works better than uh, just outright punishing people.
Yeah.
So I think, yeah, that's where I see the biggest innovations happening. But besides that, I mean, there's plenty of other recycling techniques that are being used, and as the materials become advanced, their ability to be recycled only gets better. So yeah, I mean, I think the future is certainly bright when it comes to recycling,
Yes,
for
for
sure.
sure. And we talked a little bit about it at the beginning of our conversation in terms of advancements in the plastic technology and really
Mm-hmm.
throughout. But how do you see these advancements specifically influencing the industrial sealing industry?
Yeah. So if the question is, how are the advancements kind of influencing? Yeah. So how are they influencing? I think the a few of the big ones, lower power consumption, right? So a lot of these new high performance polymers have much lower coefficients of friction, so they're much lower friction materials. Lower friction materials require less power to rotate the equipment. It's just less drag on the equipment means less power consumption, less kind of input wattage, which is lower power consumption, and that is kind of an exponential increase. So one pump which you can reduce the drag a little bit by a lower friction material, and it's using a minuscule amount less power. But you multiply that over thousands of pumps in one plant times thousands of plants across the country, and we're talking about, you know, an unheard of amount of kilowatt hours saved, right? So it's significant power. So like that innovation there, just in lowering the coefficient of friction of these materials saves tons of power, tons of power. So like that's a big deal. But better, longer lasting seals means less waste, right?
Mhm.
So a product that lasts longer and seals better is you don't lose as much material. It just kind of common sense, right? But yeah, again, you lose less material, you use less input material. So plants and manufacturing facilities become more efficient. Their costs get lowered, fewer input materials, fewer losses, all those things. So you would
All
assume
amazing things.
all amazing things, right? Yeah, and you assume that the input costs go down. Hopefully, that the cost to the consumer also goes down.
Mhm.
So all those things, like companies are more profitable. Hopefully, wages go up. So like, there's this kind of trickle effect of everything. So and it all comes back to, again, better materials, better innovation, longer lasting seals. Um, that all that impacts everything, really, you know. And I mean, you could say that for a lot of things, right? But in general, uh, performance, better performance means lower power consumption, and lower waste, which is a good thing always.
Yes, for sure. Um, so I saved the last question I have for you for the last because it's a biggie. I feel
I'm
like
ready.
it's a really hard one
Okay,
to answer because we
I'm
don't know.
excited.
But what do you think is the future of plastics?
um, I think the future of plastics is still bright, despite the current concerns. I still think that the future in plastics is bright. Is it going to look like what it looks like now? I hope not. But and I'm a plastics person, so like I'm biased. Maybe I shouldn't even be answering this question, but um I think it is still bright. And I think, again, as I said, with the proper amount of checks and balances and oversight, which we can argue if that's presently the case. I don't know, but with the proper oversight and checks and balances, and with the proper incentives towards innovation, and kind of a general focus on making things sustainable and protecting one another and the environment, um, and also making products profitable so that we can continue to make products. I think plastics is going to be a major part of our world. I do, um, if done well and right. And so yeah, I mean, what's the future? I think the future is still plastic, but um, it's going to have to be. We're going to have to take a lot more care, and we'll get there. I mean, again, people are resilient, and we make mistakes, and nothing's perfect, but I think we'll get there, and I do think the future for plastics is still bright.
Yes, for sure. So I have loved this conversation with you, and
Yeah,
I think that
absolutely.
our audience is going to as well. Do you have anything else that you would like to leave people with?
Wow. I always get asked this question, and I never know. No, I mean, yeah, I do. I'll say this: keep innovating. Like for everybody who's listening, like let's keep making good products, and let's not be so afraid of mistakes that we don't take a step and try, and then let's learn from those, and get better. I mean, that's individually, and that's as a society. We gotta keep innovating, and yeah, we'll figure it out.
I like it. Well, Cody, thank you so much for your time and your expertise in this conversation. I have thoroughly enjoyed myself and am excited to push this out and see what other people have to say about this conversation as well.
Lovely. It was a pleasure.